Hey everyone, welcome back to the channel. Today we're diving into Ansible, the open source automation tool that turns your Homelab setup from a manual mess into a clean, repeatable workflow. We'll use it to install Pi-hole with a DNS over HTTPS proxy using two powerful community roles. So what makes Ansible great? It's agentless, just SSH and Python. No client install needed. It uses clean, readable YAML playbooks you can keep in Git. It's idempotent, meaning you can run the same playbook repeatedly. And it will only apply what's missing. And what can you automate with it? Provisioning and configuring servers, deploying tools like Pi-hole, Docker, and more, applying updates across many hosts in parallel, running it all through GitLab-ci, and using battle-tested community roles via Ansible Galaxy. By the end of the video, you'll have Ansible installed, a working playbook that sets up Pi-hole and Cloudflared, and a GitLab pipeline that checks every commit for syntax issues. Let's jump in.
Step 1. Install Ansible. We'll begin by installing Ansible and ansible-lint using pipx. First we perform an apt update. Then using apt we will install pipx, git and ssh pass. Using pipx we will install Ansible including its dependencies. We do the same for ansible-lint. You see the warning in the bottom, so we perform pipx ensure path. Where we're added, you can enable pipx auto-completion, so your terminal helps you type faster. Once installed, check the version to make sure Ansible is good to go. I have to re-log in once. Step 2. Clone your Git repository. Next, clone your GitLab repo or start a new one if you haven't already and change into that folder. This will be your working directory for the playbook and any roles you use. Step 3. Install community roles. Rather than starting from scratch, we'll use two roles from Ansible Galaxy. One for Cloudflared and another one for Pi-hole. Add them to a requirements.yml file. Now using Ansible Galaxy install, we will install the roles, with -r for your requirements file and -p for the path for the roles. They land inside the roles folder in your repository. Step 4. Write the playbook. Now it's time to write your playbook. You'll define a basic task that targets your DNS hosts and includes both roles. You also set a sample password for Pi-hole inside the task variables. Then create a basic inventory file that defines which host or IP to run it against. Step 5. Lint and test the playbook. Before running anything, lint the playbook to catch syntax issues early on. Once that passes, run the playbook. If this is your first time connecting to that host, SSH into it first and accept the host key. When running the playbook, we will define the inventory file with -i. The user Ansible uses to connect with -u followed by the user, and the capital and lowercase k to tell Ansible to ask us for the user's and sudo password. Ansible will connect to your server, apply the roles and install everything automatically. After the run completes, you can verify Pi-hole is running by resolving domain through it. Step 6. Automate linting with GitLab-ci. To catch issues on every push, we'll create a simple GitLab-ci pipeline. It spins up a container, runs ansible-lint and fails the job if anything's broken. We'll also create a .gitignore file to avoid committing the roles directory. Step 7. Commit and push. With everything in place, commit your changes and push to GitLab. In GitLab, head to the CI/CD pipeline section and you should see a green checkmark confirming it passed.
And that's it. You've installed Ansible, deployed a real service using community roles, and added a GitLab pipeline for automatic checks. If you found this useful, hit the like, subscribe, and tap the bell icon so you don't miss the next one. Thanks for watching and happy automating.